Arithmetic sequences. Our next problem, we have a blank term, positive 18, another blank term, followed by another blank term, and positive 9. So the terms that we need to find out are the first, the third, and the fourth term. So to find for the value of a term, our equation is a sub n. This is equal to a sub 1 plus n minus 1 multiplied by d. So our d here, this is the common difference. Okay, common difference. So we can get the common difference from two consecutive terms. But since our given have no consecutive terms, we have to get first the d from the second and the fifth terms. The equation for the second term, this is a sub 2 equals to a sub 1 plus n minus 1 multiplied by d. Okay. Now, we do not know the value of d and we do not know the value of a sub 1. Okay. But we know the value of n. So our equation here, a sub 2, this will be equal to a sub 1 plus our n is positive 2. So this will be 2 minus 1 multiplied by d. So a sub 2 here will be equal to a sub 1 plus 2 minus 1 is 1. 1 multiplied by d is positive d. Let us call this as our equation 1. Okay, so let us now use positive 9 or the fifth term. Our equation for the fifth term will be a sub 5 equals to a sub 1 plus n minus 1 multiply this by d. Again, we do not know the value of a sub 1, but we do know the value of n, and we do not know the value of d. Okay, so just like we did with a sub 2, a sub 5 here will be equal to a sub 1 plus our n here is equal to 5. So this will be 5 minus 1 multiplied by d. A sub 5 will be equal to a sub 1. 5 minus 1 is plus 4. So 4 times d is plus 4d. This will be our equation 2. So looking at equation 1 and equation 2, we can see that we can subtract a sub 1. Oh, before this, our a sub 2 here, okay, let's change this. Our a sub 2 has a value. So the value of a sub 2 is positive 18. And the value of a sub 5 here is positive 9. Okay, so we can now solve for the value of d. So a sub 5 here is positive 9. We can solve for the value of d since a sub 1 is equal also to a sub 1 here. We can subtract the two equations. So we can subtract equation 2 from equation 1. So again, our equation 1 is positive 18 equals to a sub 1 plus d minus equation 2, which is positive 9, equals to a sub 1 plus 4d. So positive 18 minus positive 9, this is positive 9, equals to a sub 1 minus a sub 1, this is 0. Positive d minus plus 4d, this will be negative 3d. So we can interchange this. Negative 3d equals to positive 9. Divide both sides of the equation by negative 3. So negative 3 divided by negative 3, we can cancel this out. So our d here will be equal to positive 9 divided by negative 3. our d is negative 3. Okay, so we can now use d equals to negative 3 to find for the first, the third, and the fourth term. Okay, so to find for the first term, first we need to use again a sub 2. So the equation of a sub 2. Again, a sub 2, this is equal to a sub 1 plus 2 minus 1, since we now have a value for d which is negative 3. And then the value of a sub 2 here is positive 18. So we can use it here. A sub 2 is positive 18. Since still we do not have the value for a sub 1, so this will be plus 2 minus 1 is 1 multiplied by negative 3. Positive 18 equals to a sub 1. So positive 1 times negative 3, negative 3. So to find for the value of a sub 1, we will just transpose negative 3 to the other side. Okay, so a sub 1 here will be left. And then we will have here positive 18. If we transpose negative, it will change sign. This will become positive 3. So a sub 1 will be positive 21. Okay, so we are now going to find for the value of the third term. Okay, since a sub 1 has a value now, this will be easier for us to find for the third term. Our third term will be a sub 3 equals to a sub 1 plus n minus 1 multiplied by d. So we now have a value for a sub 1 that is 21 plus our n here is positive 3. 3 minus 1 multiplied by d, which is now negative 3. So a sub 3 here will be equal to positive 21 plus 3 minus 1 is 2 multiplied by negative 3. A sub 3 will be equal to 21 and positive 2 times negative 3, negative 6. So this will be equal to positive 15. So our a sub 3 is positive 15. Okay. Let us now find for the fourth term. So our fourth term now will be a sub 4 equals to a sub 1 plus n minus 1 multiplied by d. So our value for a sub 1 is 21 plus our n here is 4. So 4 minus 1 multiplied by d, which is negative 3. A sub 4 will be equal to 21. 4 minus 1 is positive 3 plus 3 multiplied by negative 3. So a sub 4 will be equal to 21. Positive 3 times negative 3, negative 9. So this will be positive 12. So therefore, a sub 4, positive 12, and a sub 3, positive 15, and a sub 1, positive 21. They are our final answers. Arithmetic sequence. Our next problem, we have positive 2, a blank term, followed by another blank, and another blank term, and then we have positive 22. So we need to find the second, the third, and the fourth term. Again, we need to find the second, the third, and the fourth term. So to find the missing terms, we need to use this equation. We have here a sub n is equal to a sub 1 plus n minus 1 multiplied by d. So our d here is the common difference. Okay. So when we speak of common difference, it is the difference between two consecutive integers. But since we do not have here two consecutive integers, we will solve d in terms of the fifth term. Okay, we cannot solve d in terms of the first, because if we will put here 1 as n, 1 minus 1 is 0, so we have to cross out d if we use the first term. So we will use the fifth term. Okay, so using the equation for the fifth term, a sub 5, this is equal to a sub 1 plus n minus 1 multiplied by d. So the value of a sub 5 here is positive 22. So we will have here positive 22 equals to the value of a sub 1, which is positive 2, plus n. Our n here is the number of the term, so this is the fifth term. Our n will be 5 minus 1 multiplied by d. Okay, so looking at this equation, our variable is now only d. We can now find for the value of d. Continuing, we will have 22 is equal to 2 plus 5 minus 1, that is 4, multiplied by d. So we have here 22 is equal to 2 plus 4d. Okay, so we can try to rearrange the equation. We will make this as 2 plus 4d equals to 22. So to find for d, we need to transpose positive 2 to the other side. So transposing, if we transpose positive, that will change its sign. But what will be left on the left side will now only be 4d. So 4d is equal to 22. If we transpose positive, this will change sign. This will become negative. So 4d will be equal to 22 minus 2, that is 20. So to find for d, we need to cancel out 4. To cancel out 4, divide both sides of the equation by 4. So 4 divided by 4, we can cancel this out, that is equal to 1. So 1 multiplied by d, that is equal to d. And 20 divided by 4 is 5. So we now have the value for d, so we can now solve for the second, the third, and the fourth term. So our second term, the equation will be a sub 2 is equal to, okay, this is a sub 1 plus n minus 1 multiplied by d. So let's check. Our a sub 1 here is positive 2. So our a sub 1 is positive 2 plus our n here, since this is the second term, our n will be positive 2 minus 1 multiplied by d. So our d is positive 5. Okay, so we have here 2 plus 2 minus 1 is 1. And 1 multiplied by 5, that is positive 5. So our a sub 2 here is equal to positive 7. Okay, let us now find for the third term. Okay, the third term will be a sub 3. A sub 3 would be equal to a sub 1 plus n minus 1 multiplied by d. Okay, so a sub 1 here, again, this is positive 2 plus n. Okay, this is 3. So 3 minus 1 multiplied by d. Again, our d is positive 5. So this will be equal to 2 plus 3 minus 1, that is 2, multiplied by 5. So our a sub 3 here will be equal to 2 plus 2 times 5 is positive 10. So our a sub 3 now will be equal to positive 12. And then let us find for a sub 4. Okay. So the formula for a sub 4 will be equal to a sub 4 is equal to a sub 1 plus n minus 1 multiplied by d. So our a sub 1 again is positive 2 plus our n here will be the fourth term, so that will be 4 minus 1 multiplied by d. Our d is positive 5. 2 plus 4 minus 1, that is positive 3 multiplied by 5. So our a sub 4, this will be equal to 2 plus 3 times 5 is 15. So our a sub 4 will be equal to 17. So again, our a sub 4 is positive 17 for a sub 4. A sub 3 is equal to positive 12, and a sub 2 is equal to positive 7. These are our final answers. Arithmetic sequences. Our next problem, we have a blank term followed by another blank, positive 9, another blank term, and positive 19. So we need to find the first, the second, and the fourth term. Again, we need to find the first, the second, and the fourth term. So to find for the missing terms, our equation that we are going to use will be a sub n is equal to a sub 1 plus n minus 1 multiplied by d. So our d here, this is the common difference. So common difference. Okay. So to find for the common difference, we need to subtract two consecutive integers. But looking at our problem, there are no two consecutive integers. Okay. A sub 1 here, this is the value of a sub 1. And since there is no a sub 1, we also need to find for a sub 1 first. Okay, let's try to find the value of the common difference first. Okay, so we are going to use the equation for the third term, since this is already given, and the fifth term. The equation for the third term, this will be a sub 3, since this is the third term, equals to a sub 1. We do not have the value for a sub 1, plus our n here will be positive 3. So 3 minus 1 multiplied by d. Okay, so a sub 3 here, a sub 3 will be equal to a sub 1 plus 3 minus 1, that is 2, and 2 multiplied by d is 2d. This will be our equation 1. Let us find for equation 2. So we are going to use the fifth term. The formula for the fifth term will be a sub 5. A sub 5 equals to a sub 1 plus, okay, our n here will be 5. So 5 minus 1 multiplied by d. Okay, so our a sub 5 here, a sub 5. Okay, so by the way, our a sub 3 has a value already. So our a sub 3 here will be positive 9. So our equation 1 will be 9 equals to a sub 1 plus 2d. So for our a sub 5, the value of a sub 5 is 19. So we have here positive 19 equals to a sub 1, and we have 5 minus 1, that is positive 4, so this will be plus 4d. This will be our equation 2. So looking at the two equations, we can subtract equation 1 from equation 2 so that we can cancel out a sub 1, and we can find for the value of d. Okay, let us now subtract 1 from 2. Okay, subtract equation 1 from equation 2. So We sub we will subtract equation 1 from equation 2 because 19 is bigger than 9 and 4d is bigger than 2d. Okay, so that we won't have a negative values. Okay, so our equation 2, we have positive 19 equals to a sub 1 plus 4d. Subtract this by equation 1, which is positive 9 equals to a sub 1 plus 2d. So subtracting, we have 19 minus 9, that is positive 10, equals to a sub 1 minus a sub 1, that is 0, and positive 4d minus positive 2d, this will be positive 2d. So we can rearrange this. We can put here positive 2d, and we can put positive 10 on the other side. This will not change the value of the equation. So to find for d, we need to cancel out 2, so we need to divide both sides of the equation by 2. Okay, so 2 divided by 2, we can cancel this out. Okay, so we can cancel this out because this is equal to 1. So 1 multiplied by d, this will give us positive d, and 5 divided by 2 is positive 5. So we now have the value for 5. Okay, let us now find for the value of a sub 1. So we are going to use the equation of the third term also. So again, the equation of the third term, this will be a sub 3 equals to a sub 1 plus n minus 1 multiplied by d. We have the value for a sub 3. The value of a sub 3, again, that is positive 9. This is equal to a sub 1 plus, okay, our n here will be equal to 3. So 3 minus 1 is 2, and 2 multiplied, okay, we have here the value for d, so 2 multiplied by the value of d, which is 5. So 9 will be equal to a sub 1 plus 2 times 5 is 10. Okay, so we can transpose positive 10 to the other side, so that what will be left will be a sub 1. Okay, we can transpose this to the other side. So transposing, we will have, okay, so transposing, we will have here 9, and if we transpose positive 10, it will change its sign. Okay, so from positive, this will change its sign, it will become negative. So this will be 9 minus 10 equals to a sub 1. Okay, let's check. So 9 minus 10 equals to a sub 1. Okay, so 9 minus 10 is negative 1, so we can interchange this. A sub 1 will be equal to 9 minus 10, that is negative 1. So our a sub 1 now is negative 1. Okay, so we have the value for the first term. This is negative 1. Negative 1. Okay, let's now find the value of the second term. So a sub 2 now would be equal to a sub 1 plus n minus 1 multiplied by d. Okay, so our value for a sub 1, again, that is negative 1. So we have here negative 1 plus our n here will be positive 2. So 2 minus 1, and our d is positive 5. So 2 minus 1 multiplied by 5. So a sub 2 would be equal to negative 1 plus 2 minus 1 is 1 multiplied by 5, that is 5. So a sub 2 would be equal to positive 4. Okay, so let us now find for the value of the fourth term. Okay, the value of the fourth term. So a sub 4. A sub 4 would be equal to a sub 1 plus n minus 1 multiplied by d. So a sub 4. Our a sub 1, this is equal to negative 1 plus n minus 1. Our n here will be equal to 4. So 4 minus 1, and our d is 5. So a sub 4 would be equal to negative 1 plus 4 minus 1 is 3. 3 multiplied by 5, that is 15. So our a sub 4 would be equal to positive 14. Okay, so again, our a sub 2 is 4. Okay, let's put it here. Our a sub 2 is positive 4, and our a sub 4 is positive 14. Okay, positive 14. So negative 1, positive 4, positive 9, positive 14, and positive 19. They are our final answers. Arithmetic sequences. Our next problem, we have positive 15, a blank term followed by another blank term and another blank term, negative 17 and negative 25. To find for the missing terms of an arithmetic sequence, okay, again, we need to find first the second. Let us first write the missing terms. Second, third, and the fourth. Yeah, and the fourth term. So again, the second, third, and the fourth term. Now, to find for the missing terms, we are going to use the equation a sub n is equal to a sub 1 plus n minus 1 multiplied by d. So our d here, this is the okay, this is the common difference. Okay, common difference. Okay, so the common difference is the difference of two consecutive terms. Now, since our given here has two consecutive terms, negative 25 and negative 17, we can find for the value of d. So our d here will be equal to negative 25 minus negative 17. So negative 25 minus negative 17, this will be negative 8. So our d now is negative 8. We can now find for the values of the second, the third, and the fourth, since we now have the value for d. Okay, so the equation now for the second term, this is a sub 2. Okay, again, our equation for the second term is a sub 2 equals to a sub 1 plus n minus 1 multiplied by d. Okay, so the value for a sub 1, again, this is a sub 2 is equal to, our a sub 1 is positive 15 plus our n here, since this is 2, our n will be 2 minus 1 multiplied by d, which is negative 8. So we have here positive 15 plus 2 minus 1 is 1. 1 multiplied by negative 8, this is negative 8. So 15 plus negative 8 is positive 7. So our a sub 2 here will be positive 7. Okay. So let's write it here. A sub 2 is positive 7. Let us now find for a sub 3. Again, the equation for a sub 3. A sub 3 will be equal to a sub 1 plus n minus 1 multiplied by d. Okay. So our a sub 1 is 15. So this will be equal to 15 plus our n minus 1. Our n here is 3. So this will be 3 minus 1 multiplied by d, which is negative 8. So a sub 3 here will be equal to 15 plus 3 minus 1 is 2 multiplied by negative 8. So a sub 3 would be equal to 15 and plus times negative, that is negative. 8 times 2 is 16, so this will be negative 16. Okay, so let's check first. Okay, 3 minus 1 is 2, and our D is negative 8. So 2 times negative 8. Okay. Okay, so this would be equal to, yes, correct. So 15 minus 16 is negative 1. So our a sub 3 is negative 1. So this will be negative 1. So let us now find for our a sub 4. Again, the equation for a sub 4 will be equal to a sub 4 equals to a sub 1 plus n minus 1 multiplied by d. Okay, so our a sub 1, let's check again. The value of a sub 1 is 15. So this will be equal to 15 plus our n here will be equal to the fourth term. So this will be 4 minus 1 multiplied by d, which is, okay, negative 8. So our d here is negative 8. So a sub 4 will be equal to 15 plus 4 minus 1, that is positive 3, multiplied by negative 8. Okay, so a sub 4 would be equal to 15 and positive multiplied by negative, that's negative 3 multiplied by 8 is 24, so negative 24. Okay, so we have here 15 minus 24. Okay, this will be equal to negative 9. So let's write it here. Our fourth term here will be equal to negative 9. So therefore, positive 15, positive 7, negative 1, negative 9, negative 17, and negative 25 are our final answers. Arithmetic sequences. Our next problem, we have a blank term, positive 1, another blank term, another blank, and positive 21. So we need to find for the first, the third, the fourth, and the fifth terms. Again, we need to find for the first, the third, the fourth, and the fifth terms. The formula for finding a missing term in arithmetic sequences is a sub n is equal to a sub 1 plus n minus 1 multiplied by d. So d here is the common difference. Again, this is the common difference. So to find for a common difference, we subtract two consecutive integers. But looking at this given, we do not have consecutive integers. So what we need to do is that we need to use the equations of the second and the sixth term to find for d. Okay, so using the equation of the second term, this will be a sub 2 is equal to a sub 1 plus n minus 1 multiplied by d. Okay, so our a sub 2 here is positive 1. Positive 1 equals to a sub 1. We do not have a value for a sub 1, plus our n is 2. So 2 minus 1 is 1 multiplied by d. So this will be plus d. This is our equation 1. And for our next equation, we will have the sixth term. So the sixth term is positive 21. So this will be a sub 6 equals to a sub 1 plus n minus 1 multiplied by d. Okay, so our a sub 6 is positive 21. So we have here 21 equals to a sub 1 plus our n is 6. So 6 minus 1 is 5. 5 multiplied by d, this is 5d. This will be our equation 2. So we can subtract equation 1 from equation 2 so that we will find the value for d. Okay, so let us now subtract. Okay, 1 from 2. Okay, so our equation 2 is 21 or positive 21 equals to a sub 1 plus 5d. Subtract this by equation 1, which is 1 equals to a sub 1 plus d. Okay, 21 minus 1 is 20. A sub 1 minus a sub 1 is 0. 5d minus plus d, this will be equal to plus 4d. Okay, so we can rearrange this. We can write 4d here, and since this is 0, so 4d will remain, and we can write 20 here. To find 4d, we need to divide both sides of the equation by 4. So 4 divided by 4, okay, 4 divided by 4 here, this will be equal to 1, and 1 multiplied by d is positive d. So 20 divided by 4 is positive 5. We have the value now for d. Okay, so let us now find for the value of a sub 1. Let us use again the equation for a sub 2. So again, a sub 2 here. As you can see here, we will have 1. Okay, we will use this. 1 is equal to a sub 1 plus d. So our d is 5. So our a sub 1 here, this will be equal to, we will just transpose positive 5 to the other side. So transposing, this will be 1. If we transpose positive, this will change sign. It will become negative 5. So 1 minus 5 is negative 4. Okay, so we have here the value for a sub 1. Our a sub 1 is negative 4. We can now find for the value of a sub 3. Okay, so our a sub 3, let us now solve the value of a sub 3. So a sub 3 here will be equal to a sub 1 plus n minus 1 multiplied by d. Okay, so our a sub 1, what is the value of a sub 1? So our value for a sub 1, this is negative 4 plus our n here will be 3 minus 1 multiplied by d. Okay, what is our d? Our d is positive 5. So 3 minus 1 multiplied by d, which is positive 5. So a sub 3 here will be equal to negative 4 plus 3 minus 1 is 2. So we will have here 2 times 5. So negative 4 plus 10, this will be equal to positive 6. So our a sub 3 is positive 6. Let us now find for the value of the fourth term, or a sub 4. Okay, so a sub 4, the equation for a sub 4, this will be equal to a sub 4 is equal to a sub 1 plus n minus 1 multiplied by d. Okay, so a sub 1 here, our a sub 1 is equal to negative 4 plus n minus 1. This will be, or okay, our n here is 4. It's not 3. So our n here is 4 minus 1 multiplied by 5. So this will be a sub 4 will be equal to negative 4 plus 4 minus 1, that is 3 multiplied by 5. So negative 4 plus 15, this will be equal to positive 11. So our a sub 4 is positive 11. Let us now find for the fifth term. Okay, so the formula for a sub 5. So a sub 5 here will be equal to a sub 1 plus n minus 1 multiplied by d. Okay, so again, our a sub 1 is negative 4, so this will be negative 4 plus our n here is 5 minus 1 multiplied by d, which is positive 5. Okay, so our a sub 5 will be equal to negative 4 plus 5 minus 1, that is 4 times 5. So a sub 5, this will be equal to negative 4 plus 4 times 5, that is 20. So this will be positive 16. Okay, so therefore our a sub 5 is positive 16. And these are our final answers.